Hi, welcome to your lesson on quadratics in standard and intercept form. Let's begin with the problem we ended with last time. We had a rectangular mirror. We knew the length is x and the height we didn't know, but using the perimeter we were able to represent the height here in using x. Once we had that, we had two dimensions which we could multiply and get the area. So this is the area formula we came up with for that one. Using that area formula we were able to graph it. As you can see, x represents, again, the length of the mirror. So as the length of the mirror increases, we can see y here, which is the y-axis is the area. We can see the area increasing, reaching a maximum, and then decreasing. So area begins at 0, ends at 0, and it can take on any values in between. By finding the average, we can see we're taking the two x-intercepts, 0 and 130, we're adding them divided by 2. So we're finding the average of the x-intercepts. We're able to find what is called the axis of symmetry right here. It's the point right in the middle between the x-intercepts, and it is actually the line of symmetry. That line of symmetry allows us to find what is called the vertex, the highest point, or sometimes the lowest point if the parabola is facing the other way. So we take the x value and we substitute it into the function. See how the x here has been replaced by the 65 we found. Substitute it in, and that allows us to find the area when x is 65. That's what this means here. The area when x is 65. And that means that maximum area, because here's x 65, the length is 65, and here's that maximum area of 4,225. That point is called the vertex. And so our vertex is 65, 4,225. Now that vertex can be found by using this general series of steps, right? To find the vertex, we first found the average between the x-intercepts. So that's what this represents here. M and N are our two x-intercepts. We find the average. That gives us this value here. That's the x value of the vertex. Then we take that x value, so see the same thing here, goes into the function right here. And that will give us the y value. And that's exactly what we did here. We had the x value, then we put it into the function, and we got the y value. So this is what this representation represents. Make sure you understand that process for vertex clearly. Okay, now that we have that tool behind us, let's look at the Golden Gate Bridge, a very famous suspension bridge. All suspension bridges have a suspension cable in the shape of a parabola. So let's look at a problem related to that. So here's the problem. Please pause and take a read through this. Okay, now that you've read it, you know that we have a function that represents the suspension cable, and we're looking for information about it. So first we're going to plot the graph. Let's see what the graph looks like. So your graph, if you used your calculator, should look something like this. Notice that the parabola goes into the negative y values. I think that's interesting they decide to represent it that way in this problem rather than having it sit above the axis, but that's fine, it's still the right shape. So we have that. First thing we have to do is find the coordinates where the graph crosses the x-axis. So we can see those are the x-intercepts here and here. On the graph they are very clear, 0 and 1200. However, that word find in the IB world usually implies you need to show some work. Rather than relying on your calculator, you need to be able to show some work to kind of basically back up where you found the values from. So how do we do that? Well, you may notice that x-intercepts always hit the x-axis, and the y-axis is the line, sorry, the x-axis is the line y equals 0. At every point on that axis, x is 0. So at these two x-intercepts, the y value will be 0. Therefore, if we can just say y is 0 in the equation, we can find out what x is. So we take our original function and we replace the y side, or the f of x part, with 0, saying we want to find out these 2 points here. So now we have that. But how do we solve this? You may remember from factoring, which we looked at when we started this unit, is that you can factor an x out of both of these things. Once you factor an x out, we have this. Okay, so x has been divided out of this first part and also out of this second part. Now we have something times something. In mathematics, the only way to get a result of 0 when you're multiplying two things is if one of those two things is in fact 0. Therefore, we're going to say either that x is 0 or this whole piece here must be 0, because that's the only way we will get a result of 0. So now this one's already solved, x equals 0. This one we can solve by adding 1.167 and then dividing by this decimal here. and that, when you divide it, becomes 1200. So notice we have found these two x-intercepts, 0 and 1200. These match what we see on the graph, and we began by making the y equal to 0 and factoring. Very important process here. Make sure you understand what happened there. Next step is to find the axis of symmetry. Of course, so I'm just going to label the two x-intercepts there. There they are. Okay, to find the axis of symmetry, remember, we take the average between the two x-intercepts. So 0 plus 1200, we add them up, divide by 2. We're finding the average, and that average is 600. We can see it's right here. That makes sense. That looks right for the axis of symmetry. Now, that is the x value, so what is the y value there? To find the y value, we put 600 into the function, so that 600 goes right into this function here, and you get a result of negative 350. And that makes sense. We can see that, confirm it on the graph, negative 350 right here. So what does that value represent? Well, it represents the lowest point of the cable, but it also tells us, well, if the cable is 350 from this axis here, that means if there was a tower here for the bridge, it's telling us right away the tower is 350 meters tall. All right, try this one. Read through the problem and see if you can find the maximum height reached by the rugby ball. Okay, so how do we begin? Well, we can have a graph, so you can graph it on your calculator, but again, it has the word find, so we're going to try to use the process of solving algebraically. So hopefully you tried the same thing we did in the last problem. We have our function. We want to know where the x-intercepts are, because the x-intercepts will help us to find the vertex. So set the function equal to 0, and I also factored out the x here. Now I set that first factor equal to 0, and I set the second factor equal to 0. I solved the second one to get 15. Now I can see my x-intercepts are 0 and 15. That makes sense. 0, 15. Great. Now that I know the x-intercepts, I can find the vertex, because again, it falls exactly in the middle of those two. It means we're going to find the average. So here's our x-intercepts. Then I'm going to find the average of those two x-intercepts. 0 plus 15 divided by 2 tells me at 7.5, right in the middle here, we have our x value of the vertex. And if we want the height of the ball, that 7.5 is not the height. That 7.5 is the distance from the kicker. We want to find the height of the ball. So take that 7.5, put it back in the function, and find out that the y value is 5.63, which is the height of the rugby ball. Last question. How about this? Oh no, it says what's the y-intercept, and what does that tell you about the ball or the kick? Well, the y-intercept is 0, 0. We can see it here. And that just tells us the ball was kicked from ground level, right at a height of 0. And finally, try C. Will the ball cross over the goalpost, which is 2.5 meters tall? We know the goalpost from the beginning here tells us it's 13 meters from the kicker. So 13 meters from the kicker is going to be here. Your job is to find out if right here, if the ball is passing over the goalpost or not. Okay, here's how we can do that. It's very simple. You put 13, your x value, into the function. So again, into this function we put 13, and we find out that the y value is 2.6. So it's just like finding the vertex. We put an x value in and we get the y value. So we basically found this point right here. So we know at a distance of 13 from the kicker, the ball is at a height of 2.6. So it is passing just over the goalpost, which was 2.5 meters tall. All right, try this one. Read that through and see if you can figure this one out here. What's the maximum height reached by this firework? Well, first, what are two methods that we've learned so far to find that max point, right? We're talking about the max point. What's the maximum point reached by this firework? What are the two methods we've learned so far to find the max point? Well, one method was just a graph, right? We can graph it and then we can find the vertex or maximum point from the graph. The second method was, of course, to find the x-intercepts and then find the point right in the middle between them, the average, right? So on the graph, I don't know if I have that value, but on the graph, we do find two x-intercepts to be these two values. So in this case, it was not possible to factor this. And that happens. When we have x-intercepts that are not going to be even numbers, often it's going to be very difficult to factor the original equation. So if you tried factoring that, maybe you saw it didn't work out like the last two problems. And that's okay. So let's rely on our calculator now. We can find those two x-intercepts in our calculator. And now we can find the average between those two. So let's try the average. So we're looking for the t value of the vertex, which is right in the middle here. The average is you add them up, divide by 2. That gives us a value of 5. Now put that 5 into the function. to see what is the actual height of the firework there. So 5 put into the function produces 6, and that matches the graph very clearly here. The point 5, 6 is our vertex. Alright, now find the positive t-intercept. Well, we have it here already. Explain what this value represents in the context. Well, hopefully for that one you said there's a value. It's that coordinate right here, and it represents the distance from the launch point at which the firework landed, right? Because at that point the firework has a height of 0, so it's where it landed. So is the distance 10.427? Sorry, 447? No, it's not, because it started here at negative 447. Or actually, you can think of it this way: since this axis represents time, oh, did I say distance? Yeah, sorry, t represents time. So this is actually the time at which the firework hit the ground. So 10.447 seconds after launch, it hit the ground. All right, and let's see. And it started at a height of 1 meter. So notice we can't go back in time, in negative time. So it started at a height of 1 meter, reached this maximum, and hit the ground here after 10.447 seconds. All right, we've talked about all these different applications of quadratics. That's what quadratics are all about. So this question for you. What's your answer to that? Okay, thank you for pondering that question. Let's look at something else. Let's say we have these 3 quadratics. Are these quadratics, first of all? Yeah, they are, for sure. If you multiplied these out, you would notice you'd get x squared, and that means they are quadratic. So these would be parabolas. So second part, expand the brackets and rewrite in another form. So expand the brackets means multiply through, multiply through, multiply through. What do you get? Check your work now carefully. Make sure you got these 3 versions after you multiplied these out. In this case here, you'd multiply these and then multiply everything by 2. And same thing here, you'd multiply these and then multiply everything by -2. Okay, now we're going to take those and graph them. So here are the 3 graphs, and the x-intercepts are labeled for you there. What do you notice? Look at the x-intercepts, look at the original form, and what do you notice? Okay, what you should have noticed is there's a clear connection between what we see in intercept form and the x-intercepts here. For example, we see -2 plus 1, and here we see -1 plus 2. Here we see -3, -7, and here we see +3, +7. So it looks like the x-intercepts are always the opposite values of what we see here. And that is an important point. So let's summarize a couple things. First of all, this is called standard form. This is called intercept form. And these are the 2 forms we've been looking at. To get from standard to intercept, we just factor this and we get this. And now these 2, it's called intercept form because these will tell us what the x-intercepts are. But they're always the opposite sign of what we see here. So let's look at this one here. We're given a graph in intercept form. We can see it here. Okay, and for that we're going to find the x-intercepts. So we're given this intercept form. Okay, here's the graph, and we can see the x-intercepts are here and here. How do we find them? We take this, and we've been talking about setting it equal to 0 to find the x-intercepts, right? So we set this equal to 0, and then we can solve each of those separately. X minus 5 can be 0, or x plus 3 can be 0. And when you solve those, you get x equals 5 and -3. And we can see that matches our 2 x-intercepts here. The axis of symmetry, find it now. And of course, you already know how to do that. Find the average between the x-intercepts. So we have 1. And then we need the vertex. So we take that x value, put it into the function, put 1 into here, and you should be able to get the y value. And then you have the vertex. Let's try one more. Let's look at this last one. Here we're given a function in standard form, so we need to change from this form to this form, means factored form or intercept form, so we can get the x-intercepts. So here we can first factor out -2, and we're left with this quadratic. If you remember the factoring technique we looked at, we look at a times c on top, b on the bottom, so a times c is -12. On the bottom we have -4. And then we think of 2 numbers that multiply -12 but add up to -4. Those 2 numbers are -6 and 2. So our factored form then is this, x minus 6, x plus 2. Then we set it equal to 0, we set each of the factors equal to 0, and we solve 2 values. Those are our x-intercepts. Now our x-intercepts help us get the vertex, but we can also get the y-intercept. this number here, we can get the vertex, and once we have the vertex, we can graph. And remember, the vertex is this technique. And check the graph, check everything, it all comes together.